Good morning, my dear students. My name is Andhane Sharma, working as physics lecturer in one of the reputed institution in Hyderabad. Today, we are going to know some of the important concepts for examination. That is this Telangana State IPE exam. Okay, so that is we are discussing about thermal expansion of matter. It is one of the weightage chapter. Okay, so from thermal expansion, definitely you will be given some questions. Okay. Thermal expansion of matter. Okay, so one of the important short answer we discuss right now. Okay, so that is about wall clock. You know, a wall clock does not show correct time throughout the year. Here you'll be given a 4 marks question. Why clock does not show correct time throughout the year? So you know, in winter it goes fast, in summer it goes slow. Why? Okay, one of the important question for 4 marks. Okay, so how to answer this question? Very simple. So I hope all of you know formula for time period of simple pendulum. Remember, T is equal to 2 pi into under root L by G, where L, length of the pendulum from point of suspension to till center of the bob is length. Acceleration due to gravity, that is all of you know it at a given place, right? So what is time period? Time taken by pendulum to complete one to and fro oscillation is called time period. Okay, so when temperature is same, no, it keeps correct time only. Say time period is T. That is when temperature is constant. Okay, no change in the time. So usually in summer season outside temperature will be more. No, so because of increase in temperature, the length of this pendulum increases. No, so whenever temperature is increased, length also increases. Okay, so whenever outside temperature increases, length of the pendulum will also increases. So what do you notice in this formula? Time period is proportional to root L. That means as you increase the length, thereby its time period also increases. Say this is length. So it will cover only this much area. No? Say time period T. But whenever length increases, see, time period will also increases. Means it will take more time, no, to complete one oscillation. So whenever temperature is constant, it keeps correct time, right? But whenever temperature increases, length increases, thereby time period also increases. Okay, time period will also increases. So that is why it will take more time in summer season, because each oscillation it is taking more time now. So that is why corresponding time period will also increases. So that is why a pendulum clock always go slow in summer season. Why? Because length is increasing now, so thereby time period is also increasing. Okay, now in winter season, winter season outside temperature will be less, so thereby temperature decreases, so corresponding length also decreases. Means it will become short. See, it will become short. So time taken by it will also decreases, right? That means time period decreases. Means each oscillation it completes quickly, right? So that is why a pendulum clock always go fast in winter season. Why? Because each oscillation it is taking less time. For example, you see when temperature is constant, say time period is 2 seconds. When temperature increases, length increases, so it will be more than 2. Okay, more than 2. That is in summer season. Whereas in winter season, length decreases, corresponding time period also decreases, so it is less than 2. Okay, so that is why a pendulum clock does not show correct time throughout the year. So how to answer this question? Very simple. So first you have to write this formula. So general formula for time period of a pendulum is 2 pi root over L by G, where L length, G acceleration due to gravity. In summer, temperature increases, so length increases, time period also increases. Okay, in summer, length increases, time period also increases, so it goes slow. So whereas in winter, outside temperature will be less. So thereby, length of the pendulum decreases. Thereby, its time period will also decreases. That means it will take very less time for completing one oscillation. So that is why in winter, this wall clock goes fast. Summer, slow. Winter. Now, about bimetallic strip. One of the important question for IPE, 4 marks. So bi means 2, you all know. Metallic strip means 2 metals rewhitening placed one upon other. Okay, so in the beginning you can observe that is both are having equal thickness. So this is usually taken at room temperature. So at room temperature it is straight. Okay, but whenever it is heated, okay, say when temperature of this metal strips is increased, it will be bending in the form of convex, such that one which has got more expansional quotient is coming outside, less expansional quotient inside. So in this case, brass is having more expansional coefficient, okay, than steel. So that is why this is upwards, convex, steel is inwards. Okay, so this is all when metal is heated. So it does not remain straight now, because both are expanded. Now steel as well as brass both expand. So one which has got more expansion quotient is coming outside. Okay, less expansion quotient inwards. So that is why it is in the shape of convex. Okay, now when it is allowed to cool. So when bimetallic strip is cooled, so there one which has got more expansional quotient will contract more. So that is why brass is coming inward, steel is outward. See, this contract more than steel. No, that is why it is coming inward. So at normal temperature, room temperature, it is straight. So whenever it is heated, this comes outward, steel inward. When it is cooled, brass inward, steel outward. So where does we use this bimetallic strip? Mainly using in automatic functioning. That is, these iron boxes, geysers, refrigerators, and fire burglar alarms. Okay. So whenever this question is given, first you should write about bimetallic strip. 2 metal strips of equal thickness placed one upon other. So when it is heated, one which has got more expansion will expand more, means convex. Okay, next when it is cooled, concave. Now we are going to know another important question which is compulsory for board exam, that is you can expect in a short answer question about anomalous expansion of water. So anomalous means abnormal, peculiar, different. That is all liquids expand after heating. No doubt water will also expand after heating. But behavior of water, especially between 0 degree centigrade to 4 degree centigrade, is different. That is, whenever you heat water from 0 to 4, instead of expansion, it undergoes contraction. But whenever it is allowed to cool from 4 to 0, instead of contraction, it undergoes expansion. So this abnormal behavior of water is called anomalous expansion of water. So suppose if a graph is plotted by taking temperature along x-axis, say volume along y-axis. So in the beginning it is having maximum volume. So as you increase the temperature, its volume is decreasing. That is up to 4 degrees centigrade only, remember. Okay, but after 4 degrees centigrade, when you heat, no, say 6, 8 and so on, its volume will increase. But volume is minimum at 4 degree centigrade. Okay, so as you increase the temperature, volume of water will decrease and becomes minimum at 4. So this abnormal behavior only you call anomalous expansion of water. So density wise, if you are taking, say, temperature is taken along x-axis and density taken along y-axis. Okay, so as you increase the temperature, between 0 to 4, volume is decreasing. Thereby, its density will increase, because you all know density is mass upon volume. So minimum volume, density is maximum. So that is why as you increase the temperature, volume of water decreasing. No, and becomes maximum density at 4 degree centigrade. More denser water is always down, less denser water is always up. No, so this is the graphical representation. Exactly reverse. See, density is minimum at 4 degree centigrade. So as you increase the temperature, see, density is becoming maximum, where at 4 degree centigrade. So it is a boon to aquatic animals. Aquatic animals like water, fish. So whereas in the water, fishes and all are surviving their life even in the winter season also. Okay, so usually fishes are on the near to the surface of water, near to the surface of water. But whereas in winter season, outside temperature will be very less, so thereby density of water is increasing. Why? Because this is the behavior of water between 0 to 4. As you increase the temperature, volume of water is decreasing. Mainly this is due to more number of bond formations, that is more number of hydrogen formations, hydrogen bond formation in water. Okay, so that is why it behaves in this way. Okay, it behaves in this way. That is, the density of water is maximum at 4 degree centigrade. Okay, so that is why you see centigrade. Okay, so that is why you see at 4 degree centigrade density is more, so more denser water is at bottom. That is why fishes are coming down and surviving their life also in winter season. Okay, so it is a boon to all aquatic animals. Okay, so remember, behavior of water is abnormal only between 0 to 4. Followed by it is normal only. Okay, So very important question. Now we are going
2, 1.
Now we are going to discuss one of the important question, that is Newton's law of cooling. Cooling means the body losing heat to surrounding. No? So according to Newton, rate of loss of heat. So dq by dt is always proportional to temperature difference between body and surrounding. So always body should be at higher temperature than surrounding. Then only the body capable of losing heat, because you all know heat always flows from a body at higher temperature to lower temperature. That means body should be at higher temperature, surrounding should be at lower temperature. And remember, this difference of temperature should be always small. Then only Newton's law of cooling is applicable. Means there should not be more variation between body and surrounding. So what is Newton's law of cooling? Rate of loss of heat is always proportional to temperature difference between body and surrounding. Or you can also write dq by dt, okay, is equal to minus some constant, say c, into theta b minus theta s. Why we are using negative sign? Because here the body is losing temperature, cooling process. So here negative sign indicates decreasing temperature. Okay, negative sign indicates decreasing temperature. So dq is always equal to, dq is always equal to mass into specific heat into difference of temperature. So you must have studied in the lower classes. So the amount of heat absorption or emission is always equal to ms delta T. No? So instead of so dq substituted as ms d theta by dt, no, equal to minus c of theta b minus theta. Yes. So mass of the body constant, specific heat is also constant. Take this to other side. So d theta by dt is equal to minus c by ms, right, into theta b minus theta s. Okay, so it is taken as some constant, say k. So d theta by dt is taken as minus k of theta b minus theta s. Okay, but whenever temperature of the body is decreasing uniformly, okay, so whenever temperature of the body is decreasing uniformly, so instead of theta b you can take average. Say the temperature of the body in the beginning theta 1, say in time t seconds it decreases to theta 2. Then in place of theta b you can write average theta 1 plus theta 2 by 2. That is if you are assuming the temperature of the body is decreasing uniformly. Then d theta by dt is taken as same constant. Instead of body temperature you should write average temperature minus surrounding. Okay, so this is about Newton's law of cooling. Now we are going to know one of the important long answer question for IPE, that is what is ideal gas, Boyle's law, Charles law, and the derivation of this ideal gas equation. So ideal gas means which obeys Boyle's law, Charles law at any temperature and pressure. Okay, if it follows Boyle's law, Charles law at any temperature and pressure, it is said to be ideal gas. But all real gases like air, hydrogen, nitrogen, okay, so these are all following Boyle's law, Charles law under suitable conditions, that is high temperature and low pressure. Remember, all real gases are following these gas laws under high temperature and low pressure. Okay, now we are going to derive what is ideal gas equation. So let us consider a gas enclosed in a cylinder whose initial pressure is say P1, okay, volume V1, temperature T1. Okay, so we are considering a gas which is enclosed in a cylinder whose initial pressure is P1. Okay, volume is V1, temperature is T1. Okay. So in the first step, we will consider Boyle's law. Okay, so what is Boyle's law? At constant temperature, the given volume of a gas is inversely proportional to pressure. So as you increase the pressure, volume decreases. You see, cycle pump. So when you push the piston down, no, pressure will be more, no, volume will be less. So as you keep temperature constant, say the pressure of the gas changed from P1 to say P2. Okay, so you are changing the pressure from P1 to P2 under same temperature. Okay, then you know its volume changes. Say that is V. Okay, then you know the volume of the gas changing from V1 to say V. So what is Boyle's law? At constant temperature, you know the given volume of a gas is inversely proportional to pressure. Means this product is constant, no? PV product is constant. So P1 V1. No? So that is equal to over here P2V. Okay? P2V. Therefore you know V becomes P1 V1 by P2. According to Charles' law, that is, you know, as you increase the temperature, corresponding volume and pressure both will increase. Because you know when a gas is heated, you know pressure changes, volume also changes. So you can keep pressure constant and you can change volume. Or else keeping volume constant, pressure can be changed. So according to Charles' law, suppose the temperature of the gas increased say from T1 to T2. Okay? Say under constant pressure. Now you are not changing the pressure. Pressure is maintained constant. You are heating the gas from temperature T1 to T2. So thereby you know its volume changes because no scope for pressure, that is kept constant. Okay, so pressure is constant, temperature changed to T2. So thereby you know its volume changes from V to V2. Okay. So according to Charles' law, you know volume is proportional to absolute temperature. So you know V by T is always constant. So here V by T1, right? V by T1 is equal to V2 by T2. Okay, so thereby you know V becomes V2 T1 by T2. Okay, this is taken as equation 2. You know from 1 and 2, P1 V1 by P2 is always equal to V2 T1 by T2. Right, now you bring all first terms one side. P1 V1 by T1. No, that is equal to P2 V2 by T2. Or else you can also write PV by T is taken as some constant. Say R. It is called specific gas constant per unit mass. So whenever you consider mass of the gas, no, you get this constant. So it is different for different gases. But in order to keep same constant for all gases, we are introduced a concept that is you all know, mole concept. No? N is mass of the gas by its molecular weight. So main purpose is to keep same constant for all gases. Okay. So when the mole concept is introduced, it is PV equal to N or T. Okay, because PV by T taken as specific gas constant. No? So whenever number of moles of a gas is taken, it is PV equal to N or T. So this R, universal gas constant means that value remains same for all gases.